Greetings, math friends. I have an interesting theorem dealing with logarithms here. And I don't feel like it, on the surface, feels like it should be true. We see that the log base A of sum B is going to be equal to the reciprocal, but with the base and the independent variable switched. Does that seem true? I wonder why that would be true. I wonder who discovered that. I don't know who discovered it. We're going to see if we can put together a proof that this is actually true. Now, we're going to have the common restrictions on A, that it can't be some value that would render the logarithm useless. B is not going to be a value that would render this ineffective as a logarithm either. So now that we've established that A and B are not going to be 0 or 1, we're going to move forward with this. So A and B are any real number except for 0 and 1. What can we do with this? Well, let's start here and move this direction. Assume this is true. Can we prove this? I'm going to use the change of base formula on this. So I have the independent variable, I have the base, and then I get to change the base. My original base was A. I want something that's in terms of base B, so I'm just going to select base B here. And then when I simplify this numerator, this is one of the basic log properties, that if you take the log of a number and the base of the log matches that number, then this turns out to be 1. And then this is actually this form, so we're already there. So almost right away, we can move from the left-hand side to the right-hand side and show that there is a very logical sequence with our basic logarithms that get us from here to here. So it's true. This is biconditional. It's an equal. So can we start here and also move to the other side? That would be a full, complete proof here. So let's see if we can do that. We want to take this and rewrite it in another form. One of the things that I can start out doing is kind of, now that I know how to get from left to the right-hand side, I can kind of reverse that idea. I'm going to start here, and I can rewrite 1 as many different logarithms. And I'm just going to do the thing that I know. If I match the base with the independent variable, that is 1. And I started out with base B. So I'm substituting 1 with log base B of B. And then we have that this is essentially the change of base formula. So I can rewrite this as the log operating on B with base A. And we're back to here. So we have shown that this is true. So that went pretty quickly as well. So even though this does seem a bit strange, we've shown that if we start here, we can land here, or if we start here, we can land here. So this theorem is absolutely true for all real numbers, as long as we don't allow A and B to be 1 or 0, which would render this to be undefined in some way. Cheerful calculations.